So let's continue our study of looking at graphs and analyzing them. So graphs can have symmetry. On the two pictures on the screen, the red dotted line is where you could put a mirror and find similar points. So for example, if I draw in blue. On the second graph, if you remember parabolas, they have an axis of symmetry. I could lay a mirror right here, and then this half of the graph would show up from the mirror from this reflection. So let's look at the types of symmetry we can have and the special classifications that we use called odd and even functions. So in general, there are three types of symmetry, three key places that we are symmetrical to on the graph. We can be symmetrical to my x-axis right here. So I reflect up and down across the x-axis. I can be symmetrical with respect to the y-axis. I can reflect over this line, y-axis, or I can reflect across the origin or the center of the graph. So let's go through these steps one by one. Let's read what it says first. It says that for number one, if I have symmetry with respect to the x-axis, if the point xy is on the graph, then the point x negative y is also on the graph. So let's look at what that looks like first. So think about this for a second. If I have a point xy, we'll call a point right here, 1, 3. If I reflect across the x-axis right here, then my reflection point is this one down here, 1, negative 3. So just like it showed, the y ordered pair switched its sign. So algebraically, what we do is we're going to replace y with a negative y and see if we get the same result, meaning I get the same thing I started with. So here's what I'm starting with. I'm going to take what I have, x minus, instead of putting a y, I'm going to put a negative y because it says replace the y's with negative y's and square it equals 1. So then we just do some algebra. X minus, in parentheses here, this negative y squared becomes a positive. The minus is still there from the equation, equals 1. And if you look, this right here is the exact thing, same thing as what I started with. So this thing has x-axis symmetry. So let's try the next one. Okay, so a similar idea or similar thought is on the next one I have symmetry with respect to the y-axis, so I'm going to reflect across the y-axis right here. So if I draw a point, I'll stick with my 1, 3 example, 1, 3, and I go across the y-axis. This time the x changes its sign, but the y stays exactly the same. So we replace the x with a negative x, and we're going to see if we have the exact same result. So here's what I'm starting with. So y equals, make sure you change the x to the opposite sign, squared plus 3. A negative squared is a positive, plus 3. And this thing right here that I have is the same thing as what I started with. So it has y-axis symmetry. Now for the last piece down here, we're going to see if I have symmetry with respect to the origin. So to graph what that looks like, I'm going to stick with my 1, 3 example. 1, 3. So if you think about this logically, to go across the x-axis, the y change signs, to go across the y-axis, the x change signs, to reflect across or through that origin, they're both going to change signs. So if this is my origin, and I'm going to reflect that dot through the origin down here, they're both going to change signs. It's going to be negative 1, negative 3. So you replace the y with a negative y and x with a negative x. So let's try this example. Negative y and then a negative x cubed. So this is just a negative y. A negative cubed is a negative. So then I divide both sides by a negative 1 because we need to solve for y. And I get that y equals x cubed, which is exactly the same thing that I started with. So this one has, not y-axis. This one has origin symmetry. So So let's try this example. Let's try to figure out what types of symmetry we have. Now, I'm by no means saying that you have to do the work my way, but I'm going to recommend it because it keeps everything organized. So what I do is I always make a table with 3 pieces. X, Y, O for origin. So for the x-axis, you change the y. So negative y equals x to the 4th minus x squared plus 3. I don't really need those parentheses. They're not doing anything. And this is not the same because I have a negative y here, but I don't have that here. So the answer here is no. I don't have x-axis symmetry. Let's see about y-axis symmetry. So for y-axis, we change the x's. So y equals negative x to the 4th minus a negative x squared plus a 3. Y equals a negative to the 4th power. Negative times a negative, positive, negative times a negative, positive, positive times a positive is a positive. So this is just x to the 4th minus x squared plus 3. This is the same as what I had. So the answer here is yes, I have y-axis symmetry. Origin symmetry, we do both of them. So negative y equals negative x to the 4th minus negative x squared plus 3. And if you look right here, this piece is the same thing that we have right here. We just did this work so we can copy it down. Negative y equals x to the 4th minus x squared plus 3. Again, I have that wonky negative y in the front, so the answer here is no. So what kind of symmetry does this have? This equation has y-axis symmetry only. So let's talk about this y-axis symmetry because it is this y-axis symmetry that does something very important and specific. If we talk about even and odd functions, what we do is we change just the x value, See, we just change the x. If I get the exact same thing out, nothing changed, it stayed the same, Same means I'm going to be what's called even, nothing changed. If I plug in that negative x like I do to check for y-axis symmetry and everything is right here, see that negative in front? That means everything is going to have the opposite sign, everything. Opposite means odd. So that's how I remember it. Opposite means I'm called odd. So let's try these. Remember, it asks us if I'm even, odd, or neither. So if you're not all the same and you're not all the opposite, then it's neither. And we're only doing even and odd, which means we only have to plug in that negative x. So just be aware that you know what's being asked of you so that you don't do more work than you have to. So let's try this. So on number 1, I'm going to do g of negative x. So that means that I'm going to get negative x cubed minus a negative x. I've plugged in my negative x's. A negative cubed is a negative. That minus sign drops down. And then this becomes a minus x. So this becomes a minus x cubed plus the minus like a plus. If you look here, these are both the opposite of what I started with. So this is an odd function. Now, it's weird. It's just called odd. The next one. So h of negative x. Negative x squared plus 1. A negative squared is a positive plus 1. These are both the same. And if it's the same, it's called even. So this is an even function. Last one. F of negative x equals a negative x cubed minus 6. A negative cubed is a negative, and there's no x in this one, so it's still minus 6. Be very careful here. This one's opposite, but this one stayed the same. So one's opposite, one's the same, which means it is called neither. It's not odd or even, and thus it is neither.